Hello students, welcome to this energy lab. Today we are going to discuss about experiment number 8, that is a variable compression ratio petrol engine test rig. Let us discuss in detail about this experiment. Okay, so the aim of the experiment is to conduct a performance test on variable compression ratio petrol engine test rig. See, here in this performance test we are going to able to find out the mass fuel consumption, total fuel consumption, specific fuel consumption, efficiency, brake power. These are all parameters we are going to find out. So let us, what is the description of this test rig? This description of the test rig, it consists of 4-stroke petrol engine that is air cooled, and to be tested for performance is going to be coupled to the AC current generator. Okay, so this arrangement is going to be made for some of the measurements for the setup. So I'll just go on discussing right now. The first one is the rate of fuel consumption is measured by using the volumetric pipette, and the airflow is going to be measured by manometer, and which is connected to the airbox, and the different mechanical loading are going to be achieved by loading the engine to the pipe, rope and brake drum assembly and attached with the weighing machine. But and also the engine speed is going to be measured by the electronic digital indicator, and temperature at the air inlet and engine exhaust, and engine water inlet and outlet temperature, and calorimeter inlet and outlet temperature are going to measure by electronic digital temperature indicator, which is connected thermocouple. Through the sensor we can read those readings, and water flow measure can be measured by the water flow meter, or we call it as a rotameter. Okay, the whole instrument is mounted on the one self-contained unit for the operations. Okay, let us discuss about what are the specifications involved in this engine. So this is a 4-stroke single cylinder air petrol engine with spark ignition, and it is made by this Graves, and the capacity of maximum power is 2.2 kilowatts, and the rated speed is 3000 rpm, and the bore diameter is given, that is 70 mm of that engine bore. So, and third one is what we are going to calculate is specific fuel consumption. So specific fuel consumption is like total fuel consumption to the brake power. So we can get the specific fuel consumption for kg per kilowatt hour, and similarly for the heat input for the engine, that is the total fuel consumption divided by 3600 into CV, that is the calorific value. As we discussed, the calorific value is the energy value of that particular fuel, and here we are considered for the petrol engine, the petrol calorific value is given, that is 48,000 kilojoules per kg. Okay, and next one is the air fuel ratio, that is air fuel ratio is the ratio of mass of the air to the mass of fuel, that we are going to find out. But already we know that what is the mass fuel consumption, we know that, but we have to find out what the mass of the air is entered into this engine. So that is 60 into CD into A into VA into rho A. So this is an equation to find out the mass of the air. So where volume of the air we can calculate by another formula, that is under square root of 2G HM divided by 1000 into rho W by rho A minus 1. So where rho A and rho W are density of the water and the density of the air, which is given, and where HM is the head of the manometer reading. So after all this calculation, you will get this 133.47 under square root of HM. That we are going to find out. So that you will get it from the reading HM. And CD of that orifice is given already, that is constant 0.62, and the area of that orifice is given, that is pi by 4 d square, where diameter of the orifice is given, that is 0.0014 meter. So these are some specification, and G is given for gravitational force 9.81 meter per second square, and the density of the air and the water are given 1.10 and 1000 respectively. Okay, and then indicated power. If you want to calculate the indicated power, we don't have any frictional power here, but frictional power is 1/3 of the brake power, so that we consider for the brake frictional power as a 1/3 of BP. Already we calculated the BP value, so this BP we can substitute in this equation. So we'll get FP, that is the total indicated power, and then the mechanical efficiency. Once if you know the BP, we can calculate it mechanical efficiency by taking the PP and IP ratio, so you'll get the efficiency. So this is the mechanical efficiency of that engine. So later once if you find out all this parameter, we can plot it on the graph, the various parameters like total fuel consumption versus BP, or brake thermal efficiency versus BP, and mechanical efficiency versus BP, and specific fuel consumption versus BP. These are the things we are going to find out. You can plot the graph. And this is the tablet column, sample tablet column I have given, I am showing now. There is a load in kilowatts and engine speed in RPM, and voltmeter and ammeter readings are there in voltage and amps, and the fuel burette readings we can see that the volume in milliliter, and this time in seconds, and air inlet and exhaust outlet of that temperature we can find out here. T1, T2 and T3, T4 are water inlet and water outlet respectively, and the exhaust outlet is given T5. So that we can operate it by a knob, and we can find out the various point of the temperature. And airflow manometer reading and energy meter reading I can identify. For every 3 revolution, we can find out the energy meter reading. So this is about the theoretical part and how we are going to conduct the experiment, and these are the calculation part. So I hope you understood this explanation. Thanks for watching. Friends, welcome to this energy conversion lab. Today we are going to discuss about variable compression petrol engine test rig. In this experiment we are going to perform, the aim of the experiment is to perform the test of variable compression ratio of petrol engine. In this performance we are going to find out the brake power, specific consumption, air fuel ratio, other parameters we are going to find out. Okay, let us see this. What is the parts of this equipment? This equipment is consist of engine and the fuel tank and burette, and this is the tank of burette, and this is a manometer reading. Okay, this is the fuel tank which is connected to the engine, and here you can see the orifice here, and this is the exhaust. So this exhaust will be there. So let us, what are the things to be noted while conducting the experiment? Okay, so we will see the how to start and what is the procedure of conducting the experiment. Okay, stop. Okay, so first what we have to do, we have to switch on the main, and so if it is blinking with the red indicate that it is on. Then here the temperature at the on the engine parts and various temperature points we can find out here. T1, T2, T3, and T1 is the water inlet temperature, and that is common at the ambient temperature, and the other one is T2 is outlet of auxiliary head and the water outlet for the calorimeter, and exhaust of before the calorimeter and after the calorimeter we can note it as T4 and T5, and this T6 is the air temperature, inlet temperature. So air is required for the petrol to make it a charge that is going to enter to the engine, and here water is going to be circulated here to measure the pressure. Okay, so with this manometer, and this is a burette to this engine, and this is a tank to the engine. So we can find out what is the quantity of the petrol is going to be taken here, and this is an engine part where we can again here the shaft will be there, that will be sensor is connected to that. Through the sensor the speed we can observe what the speed RPM is going to take place. This is an orifice, and the exhaust gas is taken through this device. Console on be on, and the engine now is get on here now. So this is on now, and the temperature is various points. Okay, T1, T2, T3, you can see this temperature that will be noted in the tablet column, and this RPM still not yet taken that ammeter reading and voltmeter reading, and this one. This is the effect of two watts. Each carries 2 watts, 50 watts, and you can up it like this. Okay. So these are the readings, and the fuel is going to be taken, and this and the engine is there. So then we can switch off this engine.